Welcome back to Rod's Radios. Today I'm looking at a Philips mains valve radio, and this is a model B6IF73A. It was made for the Irish market, so the numbers are slightly different to the normal Philips way of labeling their radios. And I got this back in 2009, and it was meant as a present for my brother, who was having a significant birthday at that time. So I cleaned it up. There was nothing really wrong with it at the time. It was working okay. So the only thing I actually did was replace the grille on the front with a new speaker cloth, fit a magic eye, and generally fettled it up by cleaning it up. And I think I also sprayed the surround a gold color to bring it back to its original state. So it was looking pretty well then, and it still looks well now. I gather the radio is still working, and the only reason I really have it now is that my brother asked me to fit a Bluetooth module inside it. Now, at the time I gave him this radio, of course, I don't think there was any such thing as Bluetooth modules. So this is the reason why we have it on the bench today. Now, I've also, in the intervening years, got some test equipment, so I can do a lot more to it now than I did to it then, certainly in the way of replacing capacitors and aligning the set. So let's take the back off and have a look inside and see what awaits us. Looking in at the back of the set, I can see that this was a fine example of a radio for its time. It has two fine, large loudspeakers here, a bass and a mid-range speaker, and a good array of valves. There's 8 valves in this radio, apart from, well, the Magic Eye is one of them, of course, and then you have the FM oscillator valve here in the FM section, an ECC85, and then you have an ECH81, an EF89, I think, an EF85, so there's 2 IF stages in between here, the EABC80 and an EL84, and of course the rectifier valve, the EZ80. So the chassis itself, it looks a little bit dusty, but that's not a problem. There's lots of cobwebs in it, of course, and the original cord, this 2-core cord is on it. Now this is going to have to be changed to a 3-core mains cable so that I can earth the chassis, just for safety reasons. So let's have a look underneath and see what lies below. And again, lots more cobwebs, but that's not a problem. But I can see here there are lots of wax capacitors, these black beauties here, which are notorious for failure, and they'll have to be replaced, of course. There's 1 or 2, there's an electrolytic capacitor in the output stage, and there should be another one somewhere in the FM detector. However, I don't see it here. But other than that, this should be a fairly straightforward repair, or at least refurbishment. And I don't see any problem in fitting the Bluetooth module to this unit. So I think it's time we took this out to the man cave. We're out in the man cave now, and I've taken the chassis out of the cabinet and removed the glass dial from the front in case that gets broken, because if that gets broken, I'm finished. So you can see the chassis in its raw state, and I've immediately identified a problem. The dial drive isn't working properly. On the AM stations, when you turn it, the needle just gets stuck and doesn't move most of the time, even though you're twiddling the tuning knob quite a lot. And when you select FM, the lower needle should move, and it does to a certain extent, but then if you can hear, there's kind of a squeaking noise. So the way it works is that in behind the control here, you can see maybe down at the bottom there are 3 rubber pinch rollers. And when I turn the tuning control, the middle one turns and either makes contact with the one on the right or the one on the left, depending whether it's the AM or FM selected. Now initially I thought the problem was that there wasn't enough pressure on moving these rollers left and right, and as you can see here I've replaced the springs that do just that, but really it's had no effect and just exasperated it really. And in the case of FM, the squeaking noise is from the shaft, from this blue roller here, sliding in between the rubber wheel that's on the outside of the shaft. So it either means that maybe the tuning gangs are stuck or seized and providing a restriction, in turn not allowing these little rollers to turn round, or else there's something else wrong. I don't think it's in the tension of the dial cords, which are pretty taut. So I think I'm going to have to disassemble the whole lot to see what's going on. And this is a horrible job because typical of Philips chassis, the dial drive goes around an inordinate number of pulleys and gears and wheels and changes from cord to wire, etc., before it does its job. So I think, however, that's the only way I'm going to get to the bottom of this. So I think it's time to bite the bullet. I'm moving the pulley connected to the AM condenser, and you can see how loose it is with the rubber grommet on the top moving laterally. So I'm going to have to investigate this a little bit further. Having taken out the tuning condenser from the chassis, you can now see how wobbly the top mounting via the grommet was in its existing setup. So I'm going to try and replace the grommet and give it a little bit more stability for when I mount it back into the chassis. I've fitted a new grommet in the bracket securing the top of the tuning capacitor, and this one seems like a much more solid foundation to support the tuning capacitor itself. So we'll see how that one works out. Well, after several hours of faffing around, I think I have it back in action. The new grommet on the top has proved to be a much more solid mounting solution for the tuning capacitor. The dial drive did come off several times during this deconstruction of the tuning condenser and back again. However, I think I have it back in action again now. I don't know how Philips ever came up with this fiendishly complicated system, but it works all right. So on AM, you can see the dial drive moves up pretty fluidly now. And when we switch over to FM, the lower needle now operates as an indicator for FM. So there we are. On to the next stage. While I had the chassis out, I took the opportunity to replace the suspect capacitors in this chassis. And radios of this vintage normally have bad capacitors in them, and this was the case here. And you can see some of the capacitors I've replaced here. The green ones here, the red ones here, some more down here, some more over here, and an electrolytic capacitor here. Some of the capacitors I didn't have the correct value, so I had to put two in parallel. That's why there are doubles here, here, and here. But if you look down on the bench, you'll see the capacitors I replaced. The ones on the left-hand side here were certainly all faulty. These are the waxy paper capacitors, notoriously bad. This is an electrolytic capacitor in the FM discriminator, and that was actually open circuit. However, the ones over here on the right-hand side, the three capacitors here, were perfect, reading absolutely spot on, which is amazing considering the age of this radio, around 60 years old. So this hopefully will make a difference, certainly to the quality of the sound, because a lot of these capacitors were in the tone shaping circuitry. So I'm expecting somewhat of an improvement when we switch this back on again. Time to do the alignment on this radio, and when I go over to the service manual, starting with the AM/IF section, it tells me to put the volume control to max, medium wave selected, etc., tuning condenser at minimum, which I've done, and then you put a signal of 452 kilocycles or kilohertz to the first grid of the ECH81, that's valve 1, via a 32,000 puff capacitor. So I've done that, and it tells me to trim S, 19, 18, 15 and 14 in that order. So here I've set up the signal generator, and I've put in a signal of 452 kilohertz as instructed, and switch it back on now because it switches itself off. And the amplitude I'm setting at minimum, which in this generator allows me to put it at 4 millivolts, but that's pretty high still. So I've brought it down and put it through an attenuator initially, just a 6 dB drop, and brought it down here, down to the radio. And it's injected here from the probe via the capacitor onto the first grid as instructed. So let's switch on the generator and see what happens. And I can hear kind of a weak sort of signal, which isn't very promising. So I'm just going to check the frequency here to see if it makes any difference when I adjust it. Now it's gone now, so I'll go past 452. Well, it's actually peaking at 457, which isn't quite right. So this is going to need a little bit of adjustment. So I'll adjust the cores here as described. And these are the AM/IF cores, 1, 2, 3, 4. So let's see if that makes any difference. And while I'm doing this, I'll switch off the speaker so it won't annoy me while the signal is still going through, and that's okay. So I'll check the reading on the avometer here, and just let's see what happens again when I adjust it. It's at 457 at the moment, and when I bring it down to 452, it certainly drops off. So it's peaking at the wrong frequency. So let's see if I can adjust it to actually peak at 452. Well, I lost the end of the last clip while I was filming this, but take it from me, I adjusted the 4 cores as I showed you earlier, and while the first 3 didn't make much difference, the last one certainly did. So that's brought up the level of the signal coming through. And if I turn it up, you might be able to hear, while it is quite noisy, it's an awful lot stronger than it was before, and that's reflected on the meter reading as well. So the IF is now aligned correctly, and if I go back to the frequency on the meter, you can probably see that it's peaking correctly now at 452, so hopefully that'll make some difference to the sensitivity of the receiver. While the radio, when I got it, was working in some fashion, the reason my brother gave it to me, in fact, was to fit a Bluetooth module to it so it could be used with an iPod or an iPhone. And this is the module that I've made up for it. It's something I use when I put Bluetooth modules into radios. And the way it works is that when the magic eye in this radio switches off, in other words, when you select the gram input or the phono input, the module here senses that and switches a relay in one direction or the other. In other words, to power the Bluetooth module only when the gram button or the phono button is depressed. So the way it works is that in comes 6.3 volts AC into this little socket here, which is fed from the heater chain. And this is rectified by a diode to give about 8 volts DC, smoothed by a capacitor, little LED lights, totally not necessary at all, but I like LEDs to show that you have power at this point, at which it now powers a transistor over here. And this transistor is switched by the absence or otherwise of the HT coming in at this socket here, which switches the transistor, switches on or off this relay, and either supplies power or not, as the case may be, depending on whether the gram button is pushed. It then feeds it onto a regulator, which gives 5 volts out, there's about 7 or 8 volts coming in, but it gives an even 5 volts out, which is what the Bluetooth module requires. And prior to going to the Bluetooth module, it goes through a 5 volt isolator to keep the voltage on this side of the circuit completely independent of the voltage on this side. So we've 5 volts DC coming into the Bluetooth module, and this is it. This is it here, the little circuitry that creates all the magic. And it picks up, there's a little aerial on the top, or a little zigzag aerial printed on the top of the panel here, which picks up the Bluetooth signal from your iPhone or your iPod or whatever, and transmits it out to this socket area here, although I don't have a socket in it, because I found that you actually need a slightly higher level of signal coming out here to feed into a tube or a valve radio. So I've added on a little extra preamp module here, which is powered by the same 5 volt DC power supply feeding the Bluetooth module. So the sound now comes out through here and is fed through wires into the body of the radio itself. You can also see the 2 plugs that I've prepared here. One has the 6.3 volt AC ready to go into the module here, and the other is the HT line to feed the switching circuitry here. So let's see how this works. By now I have the Bluetooth module sitting outside the chassis, but it's all wired up and ready to go. So if you look at the radio and look up towards the top of the picture, you may be able to see the magic eye, which is illuminated because I've selected FM. And just to show you, the radio is actually working. And sounding pretty good. So again, if you look at the magic eye and I switch over to the pickup selection, the magic eye switches off, the Bluetooth module activates, and now it should be picking up a signal. So I have an iPad here with some what I hope is royalty-free music. So let's see what it sounds like when I press play. Yeah, that sounds pretty good to me. There were a couple of paint chips missing from the front of the radio around the escutcheon, so I've decided to strip the paint off and start again and respray it. And here I have the paint stripper, or whatever you call it, applied to the front, and I leave it for about 10-15 minutes and then try and take it off. That's the first layer of paint taken off, rubbed off with a rough scouring pad. Time to let it dry and do a second layer. Sometimes this may take 3 or even 4 layers before it's completely stripped, but let's see how it goes anyway. Second coat of stripper has been on for half an hour at this stage, so it's time to wipe it off and see if it gets any cleaner. Well, that's got rid of most of it. Maybe one more coat and then I'll leave it at that. I should be able to spray over the rest of it. In fact, I didn't have to give it another coat of stripper, because with a little bit more vigorous cleaning, I was able to get the majority of the original paint off. Now, there are small remnants of paint, as you can probably see from here, left on the front, but the new respray hopefully will cover up all that. Time to get masking. Take two. We're all masked up now, so ready for a spray job. So I let that dry and give it another coat in about half an hour. Several layers of paint later, the cabinet was now finished, and the only other thing I had to do was to clean the escutcheon around the magic eye. And this I did by, again, stripping back whatever lacquer that was on it back to the plain brass, nice shiny brass finish, at which point I gave it a spray layer of clear varnish. So it's looking pretty spiffy at this stage. And then on to the final job. I reassembled all the pieces back into the cabinet, fitted the chassis back in, and at the same time mounted the Bluetooth module. And the only modification I made at this stage was to take out the little blue LED that was on the module originally and bring it out to the front panel so that you could actually see a blue light flashing whenever Bluetooth was selected on the radio. So other than that, we're ready to run. So here we are back in the kitchen, and it's looking good and sounding good. This is one of the AM stations we get here on Longwave in Ireland.
That's exactly it. Well, for the vast majority of students...
However, most of our stations here come from the FM area, and I'll just tune through it to see what we've got, starting down at the bottom.
Manager Ushi McCon. Be even.
So just putting us in touch with the people in the youth centre next door, so we can...
On the race, so there's a bit of sustainability about what we're doing. You know, in Division 1, it's...
let them go or put them...
Access to, practical exams. You know, the people, students have been telling me they've been doing exams by video submission.
So plenty of stations on FM, that's for sure. And so to Bluetooth, when I switch over to the pickup and turn up the volume, I get the welcome tone that comes through to show that the Bluetooth is working. And then on my iPad, I press play, and hopefully we have some royalty-free music. And it works beautifully. So, if you have been, thanks for watching.